Hi everyone, welcome for today's class. Last class we discussed the superposition principle. In this class we will do some numericals based on superposition principle. So first I will do a question from textbook. Question number 1.6 of the textbook. Question number 1.6 of the textbook. See, so read the question. Find the 4-point charges QA 2 microcoulomb, QB -5 microcoulomb, QC 2 microcoulomb, and QD -5 microcoulomb are located at the four corners of a square ABCD of side 10 centimeter. What is the force on 1 coulomb charge, 1 microcoulomb charge placed at the center of the square? So you have a system of charges. You have to apply superposition principle. So this is the square, right? This corner I name it A, 2 microcoulomb. You have to name the corners. B, here minus my 5 microcoulomb is placed, and C 2 microcoulomb, and at the corner D -5 microcoulomb. So this is a system of 4 charges. So side of the square is 10 centimeter given. You need to find out the force on 1 microcoulomb placed at the center of the square. Let me join the diagonals. Okay, you have to place 1 microcoulomb charge at the center. See, center I named as O. You need to find out the total force on O. So according to the superposition principle, you have to add the vector sum of all the forces on it by all other charges. Now listen. See, the charge at the corner A exerts a force O on O, charge at the center O. And these are positive charges, so it will be repelling. So force on O due to A will be, I am representing as FOA. That will be along the diagonal downward. Okay, because both are positive charges. A repels 1 microcoulomb at the center. Now, from the vertex B -5 microcoulomb, it attracts the charge at the center. So force is in this way. This I am writing as FOB, force on A due to the charge at O. Now, charge at C repel 1 microcoulomb in this way. This is taken as FOC. Now, fourth charge attract in this way towards it. So FOD. And you can see FOB, or you consider FOC and FOA. These are equal and opposite. Why they are equal and opposite? Charges are same, distance are also same. Distance from each vertex to the center is same. So FOC is equal to minus of FOA, right? They are equal and opposite. Similarly, you can see FOB is minus of FCD, right? So FOB and FOD, FOB and FOD are equal and opposite. They cancel. Similarly, FOA and FOC are equal and opposite. They cancel all the forces. So therefore, the net force on the charge at the center is 0. So charge at the center experience 0 force. Okay. Now I will give you another question. Okay. Another question. Suppose I am placing 4 charges Q on the vertices of the square. Okay. And you are going to find out the force on one charge at one corner. See the question I will give you. Four charges, each of magnitude Q is placed at 4 vertices of a square of side D. Okay. Calculate the force on the charge at the vertex D, capital D. This is the question. So we have to draw the square. This is a square. Name it A, B, C, D. Draw the diagonal. Here each charge is Q. All the corners charge is Q. Now you draw the vertex. Okay. Diagonal. Sorry, you draw the diagonal, not vertex, diagonal. So I'm joining the diagonal BD like this. You are asked to find out the force on the charge D. Now you look at the charge D, the charge at C, repel charge D. So the repel C force is in this way. This I am writing FDC. Charge at A repels the charge at D. This force I am writing as FDA. Now one more charge at V. It will exert a force it will exert B. Charge at B exert force in this way along the line BD, right? This is FAD, AB, FAB. Now listen, so these are the 3 forces acting on the charge at the corner D. Now listen, you see FD and FDC and FDA. They have a resultant. So I'm writing, this was what? FDC, right? And this was FDA, right? Okay. And these two forces are equal only, FDC and FDA, because side is D only, same. So force between A and D and C are equal. And the resultant of these two forces in this way. This I am writing as, say, F3, right? This force I am writing, resultant of FDC and FDA is F3. And you know, there is one more force in that direction. That is what? FAB. So what is the net to force on the charge at D? Therefore, net to force on the charge at D is F is equal to this F3 plus FAB. Okay. Okay. And F3 now you can find out. F3 is the resultant of FDC and FDA. F3 is equal to the resultant of FDC and FDA. So F root of FD square plus FDA square plus 2FDA FDB cos 90 degree. You know the vector equation for resultant. F1 A square root of A square plus B square plus 2AB cos theta. Theta angle between the vectors. So what is the angle between the vectors FDC and FDA? 90 degree. So this will be, you know, FDC. FDC is the force between charges at A and C. Charges are same. Charges, same charges. Distance D only. So similarly, FDC and FDA, their magnitudes are same, right? Because same charges separated by the same distance. So we can write this as FDC square plus FDC square plus this term is 0. Okay. So what is the equation? F3 root of FDC square into 2. So we can write root 2 times FDC. Now total force F3. What is F3? What is FAB? FAB is the force between the charges. Which all charges? Force between the charges B and D. So what is the distance between B and D? Diagonal. Diagonal is root 2D. So we can write FAB as 1 by 4 pi epsilon 0 Q into Q, that is Q square only, divided by diagonal. Diagonal is root 2D, right? Now you can find out the total force. What is the net to force? Net to force on the charge at D. F is equal to this F3 plus FAB equals F3 is what? Root 2 FDC plus 1 by 4 pi epsilon 0 I write as K Q square by root 2D. Now what is the force between D and C? Force between D and C. What is the force between D and C? K into Q square by D square, right? So this can be written as root 2 into k q square by d square, right? Here FAB is what root 2 d square was there, right? FAB, what is the force between the charges at the diagonal? 1 by 4 pi epsilon 0 q square by root 2 d is the diagonal, it's square. So root 2 d square, here there is root d square, right? Root 2 d the whole square, it is, right? So root k root 2 k q square by d square plus k q square by 2d square. Okay, so you can take k q square by d square common into root 2 plus 1 by 2. So if you simplify k q square by d square upon into 2 root 2 plus 1. So this is the answer for the net force. Okay. Now we will do another example. Children, these questions are simple, but it is important also. For board exams, questions based on appear frequently. I will give another question. A charge Q is placed at the Q is placed at the center of the line joining two equal charges. Two equal charges. A charge Q is placed at the center of the line joining two equal charges. Capital Q. Show that the system of three charges the system of three charges will be in equilibrium if small q is minus q by 4. So read the question. A charge q is placed at the center of the line joining two equal charges, capital Q. Show that system of three charges will be in equilibrium if q is minus capital Q by 4. So what you have to do it, first you draw the diagram. Capital Q, one charge, another charge is capital Q. So these are the system of two charges, equal charges. Now you are placing another charge at the center. Say the distance between these two charges are. Place a small charge Q at the center. Okay. The condition is system of three charges will in equilibrium if Q is minus 3/4. See, if the system is in equilibrium, the condition is the total charge, total force, any one of the charge must be zero. The net force on all the charges must be zero. This is a condition for equilibrium. Okay. So the system will be equilibrium if the net force on each of these charge is zero. So I am this point I am taking as A, this point I am taking as B. And this distance is at the center R/2. So what is the force on A? See, the charge B exert a force on A. And charge at the center Q exert a force on A. So net force on A will be FAB plus FAC. That must be equal to 0. Okay. For the system to be in equilibrium, the net force on each charge must be 0. I am finding charge on A. I am finding force on A. Net force on the charge A. Charge at A. So net force on charge at A. See, what are the force on charge A? Charge B exert a force on A. That means FAB. Plus charge C exert a force on A. That is FAC. That must be 0. So I am putting the value of FAB. K. What is the charge on A? Capital Q. Charge on charge B, capital Q by R square. Plus FAC. That means force between A and C. K. Charge on A is Q. Charge at the center charge C is small q divided by distance is R/2 square. Okay. That must be 0. So you can cancel K from both sides. 1 Q you can cancel, capital Q. Remain is capital Q by R square plus 4Q by R square equals 0. You can cancel R square also. So you are getting capital Q plus 4Q equals 0. That will give you 4Q is minus capital Q. 4Q equals minus capital Q. So that will give you small q is minus capital Q by 4. So you proved it. Okay. So remember, for the system to be in equilibrium, the net force on each of the charge must be 0. Okay. So that is proved. Now we can do one more question. Three-point charges, 2 microcoulomb, -3 microcoulomb, and -3 microcoulomb are kept at the vertices of an equilateral triangle of side 20 centimeter. Three charges of +2 microcoulomb, -3 microcoulomb, and -3 microcoulomb are kept at the vertices A, B, and C respectively of an equilateral triangle. Equilateral triangle of side 20 centimeter. As shown in the figure. What should be the sign and magnitude and the magnitude of charge to be placed there? At the midpoint of side BC. At the midpoint, that midpoint name is given as capital M. At the midpoint, capital M of side BC. So that charge at A remains in equilibrium. So that charge at A remains in equilibrium. Okay, the diagram is given. Okay, so this is an equilateral triangle. This is 2 microcoulomb. This vertex is A. Here -3 microcoulomb. Here -3 microcoulomb. Side is 20 centimeter. Now the midpoint of BC. This point is B. This point is B. This point is this point B, C. the midpoint M. Okay. And distance from B to the point M, you know, it is an equilateral triangle, so 10 centimeters. So according to the question, you have to find out the charge placed at the point M. Suppose you are placing a charge Q at M. You need to find out the magnitude and sign of the charge so that the charge at the vertex A is in equilibrium. You know, for the charge at A to be in equilibrium, the net to force on A must be 0. So we have to apply the superposition principle and find out the net total force on A, equate it to 0. Then you can find out this small q. Okay. So what you have to do? You have to find out the net to force on the charge A, equate it to 0. Now, see, the charge B minus 3 microcoulomb attracts A downward. This force I write as FAC, right? Similarly, the minus 3 at the C, vertex C, attracts. This is FAC. Okay. And there will be a resultant of these two. This angle is 60 degree, equilateral triangle. So the resultant of FAC and FBC and FAC. Okay, the forces due to B on A is FBC, FAC. There is a resultant. That resultant will be downward. Okay, this I denote as F. Now you know the resultant of FBC and FAC is downward. So there is another charge at M. So it will repel the charge at A. Then only net to force on A can be 0. So what we had to do, the force due to small q, that I am writing as Fm. That Fm must be opposite. F and Fm must be opposite. Then only net to force on charge A can be 0. So what should be the sign of the charge Q? So Q should repel the charge +2 charge at the A. So small q should be positive. Okay. Now we can apply superposition principle. According to superposition principle, F plus Fm must be 0. Okay. What is F? F is the resultant of FBC and FAC. So F I am writing root of FBC square plus FAC square plus 2FBC FAC. What is the angle between FBC and FAC? 60. Cos 60 plus this Fm. What is Fm? Force between Q and M. That you can write as K into small q into 2 into 10 raised to -6 divided by what is the distance between A and small q? AM square. This must be equal to 0, right? Now, force between AB and BC are the same. Why? Charges 2 and -3, 2 and -3, both cases. Distance also same. So we can write this as root of FBC square plus FAC also FBC square plus 2FA FBC FAC cos 60. What is cos 60? It is 1 by 2 plus K Q 2 10 raised to minus 6 by AM square equals 0. Now what to do? This FBC and FAC are same. So 2 cancel. So this become root of 3 FBC square plus KQ 2 into 10 raised to minus 6 by AM square equals 0. Okay. Now root 3 into FBC plus KQ 2 10 raised to minus 6 by AM square equals 0. Root 3 into what is force between B and C? K. What is the charge Q1? Force between B and C. Charges are 2 into 10 raised to minus 6 into 3 into 10 raised to minus 6. Don't consider minus 3 because we have considered direction downward because of the negative sign. Divided by what is BC? BC is 20 centimeter. So 2 into 10 raised to 20 into 20 into 10 raised to minus 2 the whole square plus K Q 2 10 raised to minus 6. What is AM? See, from the triangle you can apply Pythagoras theorem, right? So I'm writing on the side, what is this AM? AM equals root of AB square minus BM square, right? Pythagoras theorem. So root of what is AB? 20 square minus BM is 10 square, right? So root of what you are getting? 400 minus 300 is equal to root of 400 minus 100 equals root of 300. So you are getting root 3 into 10. This is in centimeter, right? Now you have to put the value in the equation. What you are getting? Root 3 into K into 2 into 10 raised to minus 6 into 3 into 10 raised to minus 6 by 400 into 10 raised to minus 4 plus K Q 2 into 10 raised to minus 6 by AM square. What was AM square? This is what? This distance is this distance we found is AM only, not AB. AM, right? So root 3 into 10, the whole square. But this you have to convert into centimeter also. Root 3 into 10 into 10 raised to minus 2 the whole square equals 0. Now you can cancel many terms. You can cancel this K, you can cancel 2 into 10 raised to minus 6, you can cancel. Then 10 raised to minus 4, you can cancel. So what is the remaining? root 3 into 3 divided by 400 equals minus q into q divided by 3 into 100. So this 100 and 100 you can cancel. So what will be q? Q will be negative 9 root 3 divided by 4. So this is the answer. If you simplify it, this into 10 raised to minus 6 will come. Ten raised to minus 6. If you simplify, you will get 2.25 root 3 microcoulomb. So this is how to solve this question. Okay. If this question is asked in the examination, you will get 3 marks. Okay. So this numericals, everything you have to practice many times. If you read it, it will not work for you. Okay. If you want to remember and solve the question, you need to practice it. Always physics learned by writing. Okay. So we will stop today. Remaining we'll do in the next class.